Hello, today we're going to take a look at this definite integral. It might look a little scary at first, but it's actually a really good example of how to leverage U-substitution. So here we have the integral from e squared to e cubed of the natural log of x squared all over 2x. The first thing that I notice here is we have the natural log of something raised to a power. So I'm just going to use the power rule for logarithms, which is something you should know, have in your back pocket when you're solving problems like this. And I'll link a proof to why this is true, but we can take that power down, and that's going to help us with simplifying the expression inside of the integral. Okay, so this 2 comes down, and we have 2 times the natural log of x, using our power rule, all over 2x dx. Okay, so that's really nice because now these 2's cancel out. So I'm just going to rewrite the integral from e squared to e cubed. We have ln of x now just over x dx. So now we're going to use U-substitution. When we do U-substitution, we look for an expression and its derivative. So I know that the derivative of ln of x is 1 over x. So that's going to be really helpful, and I'm going to choose u to be ln of x for that reason, because I see ln of x derivative in the expression that's in the integral. So if you use ln of x, du is going to be 1 over x dx. So that's just kind of our little sidebar there. Now let's substitute back in. So starting with our limits here, we want our integral in terms of u, not in terms of x, so we're going to have to change those. So now we're going to plug this in as our x value here. So our new limit in terms of u is going to be ln of e squared. And then our new upper limit similarly will be ln of e cubed. And rewriting this part here, now ln of x is u, and then 1 over x here, and the dx here just becomes du. So now we've done our substitution, but I want to simplify this a little bit more. So using the power rule again, we have ln of e squared. So we see that power, and we know based on our logarithm rules, you can bring that down, and we would have 2 times the natural log of e. But we also know that the natural log of e is just 1, because if we have base e, and we're solving for e to what power equals e, that's just going to be 1. So we have 2 times 1, which is just 2. Sorry, this is a 2 here. Okay. So we have that, again, as a little sidebar. And we're going to substitute for our limits here, just so we don't have to worry about that later. So down here we have a 2, and then same thing, ln of e cubed is just 3, based on this same reasoning. And I'll just copy over the u du. So now it's just a simple integral, simple definite integral. We know how to solve for the integral of u. That's going to go up by 1 power to u squared. Since it's just u alone here, we know that we need to divide by 2. If you were to take the integral, if you were to take the derivative, that 2 would come down. So we need this 2 here to cancel out the 2 that would end up in front of u. And now we're going to evaluate it from 2 to 3. So I'm going to pull out that 1/2. And then we'll have our upper limit, 3 squared, minus our lower limit here, 2 squared, and so that's just 1/2 times 9 minus 4. And so this expression here is 5. So we end up with 1/2 times 5, which is just 5/2. And so that's our final answer.